Alright, this is 7.3 confidence interval for proportions. Alright, this is a lecture video. Now, when we're dealing with the proportions, it has to have a binomial setup. Alright, which is going to lead us to a lot of things. Proportions is actually very important. Right now we're in an election year, and if this is an election year and we're rehashing these videos, anytime you look at one of those polls, they always talk about plus or minus 3%. You know, this is how they're doing it. This is a proportion. It's a percentage. You're either saying yes or no to an answer. It's very much so a binomial. So with that in mind, let's go through this. All right, so we're trying to estimate the true proportion P given, our guesswork, given a sample. So what we're going to do is we're going to take P hat, which is our sample proportion, plus or minus Z alpha over 2 for the confidence level, multiplied by the square root of P hat Q hat over N. Let's talk about where this stuff comes from. And again, remember, we have our best guess for the proportion. Our point estimate is P hat, and our margin of error is over here, Z alpha over 2 times the square root of P hat Q hat over N. Alright, so here's what we need to remember. Mu is N times P when you have a binomial. So now what we have is an X bar, which is just going to be N times P hat. Q is always 1 minus P, so in this case, Q hat is going to be 1 minus P hat. Remember, for a binomial, sigma was equal to the square root of NPQ. With great algebra, you can figure out why this is, but sigma over the square root of n, which is what we used back in 7.1 when we were first doing our confidence intervals for z, becomes this thing, the square root of p hat times q hat divided by n. Alright. Now, the only other little thing we need from the lecture is, anytime you're doing statistics, we're going to err on the side of covering ourselves. So in that case, if p hat is not known, use the worst case scenario. In other words, the worst case scenario is we want to maximize p hat and q hat, and that would be 0.5 for p and 0.5 for q. Now, this isn't going to come up until we actually do a practical, and we're trying to figure out how many people we have to survey for a certain margin of error. Just like we did in 7.1 and we had to get n, we're going to do the same thing here to figure out how many we need in order to do a proportion test. How many samples we have to take. That's where this last little portion will come into play. So, going back to original. Just like we had before, our point estimate plus or minus our error, our margin of error. And in this case, our margin of error is Z alpha over 2 times the square root of P hat Q hat over N. I'll have 2 more videos for 7.3, one of them dealing with N, and one of them dealing with the practical problem to get a confidence interval of the true proportion.